Hello, and welcome to the study guide for the AZ-700 CERT exam prep. For the next about an hour, or maybe a little bit longer, I'd like to do the reading and talking for you. The idea here is that you would listen to this recording once, maybe twice, maybe three times, while you're walking your dog, while you're in a bus, on a plane, just driving to work, whatever it might be. The focus of this session is to give you a review of the study points that are the stated objectives for the AZ-700 exam. And that exam is focused on designing and implementing Microsoft Azure networking solutions. Now, if you notice in the bottom left corner of this slide, there are some links to the deck itself, to a YouTube video, and to a study guide for the AZ-700 exam that can also be helpful in preparation efforts. Now, the goal of the session is pretty straightforward. I want to ensure that you have the knowledge that you need to take the exam and to pass it. That means that if you listen to this recording and supplement it with reviewing the links in the deck, you should be pretty well prepared to take the exam. And you may also be ready to start tackling some of your own Azure networking projects as well, which is really the goal. Now, as you use this deck, make sure to put the deck in slideshow mode so that you can see all the diagrams and any animations. The deck itself can be found at the link in the upper right corner, https://aka.ms/az-700 deck. So you can pull that down and review the deck on your own machine. So let's talk about the AZ-700 certification itself. The ideal candidate for this exam is someone that should have subject matter expertise in planning, implementing, and maintaining various Azure network solutions. That might include things like hybrid networking, connectivity, routing, security, establishing private access to different Azure services. Now, if these are areas that you haven't really worked on very much, that's fine. But the exam will be a little bit challenging. It will test your ability to read and apply the concepts to real life scenarios. Now, the study guide that's listed here, the second line in blue, is from Charbel Nemno. He's an MVP, a Microsoft MVP. And the study guide lists all the key exam objectives. So you can either just click the link here in the deck, or you can search for this study guide by its title, and it'll pop up in your favorite search engine. Most of the reference links that I have throughout this presentation came from Charbel's blog. I might have selected or referenced some other ones as well, where I thought maybe there was a better match to the objectives. But really the idea here is to think of this video like an audio book that you can study by. I've done the reading for you. I've looked up the information on your behalf. So you can kind of just sit back and try to absorb as much as you can to get a high level overview. And then if there's areas that you feel like you need to understand a little bit better, well, click on the links in the slides and do a little bit of a deep dive into those areas. When you take this exam, the resulting certification that you have is the Azure Network Engineer Associate Exam. That's the little badge that you see up in the right-hand corner. The skills that are measured on this exam will frame out the 5 modules that we're going to review to help you get ready to take this exam. And those 5 modules are listed here. They are design, implement, and manage hybrid networking, design and implement core networking infrastructure, design and implement routing, secure and monitor networks, and lastly, design and implement private access to Azure services. So those are the areas that we'll be covering in this presentation, and these are the areas that we'll be focused on in the exam. Now, they're not all covered to the same depth. Some of them, they're more heavily emphasized in the exam, but you will need to know bits and pieces from all of them in order to successfully pass the exam. The exam objectives. It's very important to know the exam objectives, and I've given you the link that gives you a quick redirection to the exam objectives as stated by Microsoft. These will tell you exactly what topics will be covered on the exam. Now, if you didn't go through and review these, you just really can't be adequately prepared to take the exam. The exception to that would be if you have kind of been there, done that. Day to day, you're configuring Azure networking products. But even then, there are often topics on the exam which some people may just never get their hands on, scenarios that they never see in real life. So it's a good idea to review the exam objectives. This will help you to quickly determine the things that you need to look a little bit deeper into and figure out the things that look familiar. If something does look unfamiliar, if it seems like something that you haven't seen before, then those are the topics that you'll need to study in the docs, or ideally get hands-on with that type of product or solution. The second bullet point refers to the MS Learn content. And to be honest, the MS Learn content is really very good for exam prep. I would recommend going there first if there are topics discussed in this video that are maybe a little foreign to you, a little unclear to you. The content in the MS Learn sections is organized according to the exam objectives. So go to the MS Learn content and find the exam objective that you're curious about. You can go straight to the area where you feel like you need to learn a little bit more. Now, as of today, the day that I'm recording this video, December 3rd and 4th of 2021, I haven't found any practice exams for the AZ-700, but once there are legitimate practice exams, like from Measure Up, they're another good way to determine what areas you may need to study with a little more focus on. Typically, when I take the practice exams, I'll configure them so that they always show me the correct answer as I go through the exam. So that even if I get the answer right, the explanations are often very valuable to me as a memory aid. They help me understand why an answer was correct. So maybe I did a little bit of a guess on it. I was kind of confident in the answer, but the explanations help me to reinforce my understanding of that concept and help me understand why the answers were correct. And that can be a big help during the exam to have that reinforcement of your knowledge. Another thing that's extremely valuable are the tutorials that you'll find in our online documentation. Now, I know for a fact that some of the tutorial content that I walked through for the AZ-700 exam was almost identical to some of the questions that I got on the exam. So it's a good idea to walk through the tutorials as a way of preparing to take the exam. So, are you ready? Let's get started with the first section. The section is dealing with designing, implementing, and managing hybrid networking. Now, when an organization migrates their resources and services to Azure, the people that are responsible for architecting the network need to ensure that communication between an on-premises network environment and the Azure network environment is both secure and reliable. one of the most common ways to accomplish the connectivity between these two networks is by using a VPN. And there are a couple different kinds of VPNs. So the one that we're talking about here on this slide is a site-to-site VPN. A site-to-site VPN is used to connect to trusted networks. So in this case, in the diagram, you've got your on-premises network and the network that's been built in Azure. When you're integrating your on-premises network with Azure, there needs to be some kind of a bridge between them. A VPN gateway, which you see in the middle of this diagram, is an Azure service that provides this bridging functionality. So your VPN gateways support a variety of different connections, but each virtual network can only have a single VPN gateway, and all the connections to that VPN gateway are going to share the same available network bandwidth. VPN gateways can also be used for connections between virtual networks in Azure. So when you create a virtual network gateway, you need to specify the gateway SKU, the type of license that you want to use for that virtual network gateway. So you'll want to select the gateway SKU that meets your requirements, and that might be based on the type of workload that you're deploying in the virtual network. It may be dependent on the throughput that you require, features that you require, and even SLAs that you require for those virtual network gateways. Now, the feature set is important to know because you may get exam questions that ask you which kind of gateway to set up. And you'll need to know what can be done with each kind of gateway. Now, policy-based VPNs, and we kind of reference that in the red box there. Policy-based VPNs are used to encrypt and direct packets through an IPsec tunnel that is based on IPsec policies that are configured between your on-premises network and your Azure virtual network. There are a couple things you need to keep in mind when you're using a policy-based VPN, and these are limitations. So policy-based VPNs can only be used on the basic gateway SKU. So as I mentioned before, it's important to know which SKUs can support which types of features, and this is one of those. So policy-based VPNs can only be used on the basic gateway SKU. That means that this VPN type, a policy-based VPN, is not compatible with your other gateway SKUs. You can have only one VPN tunnel when you use a policy-based VPN. You can also only use policy-based VPNs for site-to-site connections and only for certain configurations. Now, because of these different limitations, in most cases, you're going to use a route-based VPNs as your preferred SKU or as your preferred VPN gateway configuration. So route-based VPNs. Route-based VPNs use routes in the IP forwarding or routing table in order to direct packets into their corresponding tunnel interfaces. The tunnel interfaces then encrypt or decrypt the packets in and out of the tunnels. There are several different options that exist for achieving high availability of your VPN, and some of those are setting up as an active standby, active VPN gateways. You can have dual redundancy gateways in Azure and on-premises, and a variety of other configurations. But there's different ways that you can achieve high availability for your site-to-site VPN connections. So continuing a little bit more on the site-to-site VPN connections. Again, just to reinforce what it is, This type of VPN gateway, the site-to-site VPN gateway, lets you create a secure connection to your virtual network from another virtual network or from a physical network, for example, on premises. When you set up a site-to-site VPN, there are a couple things that you'll need to take into consideration. First of all, the IPsec and IKE policy only works with specific gateway SKUs. So take a look at the links on this slide and make sure you know which specific gateway SKUs will work with an IPsec IKE policy. If you're using an on-premises VPN device from a third-party vendor like Cisco, for example, make sure you consult with that vendor to ensure that your policy, the policy that you're planning to implement, is supported. Site-to-site and VNet to VNet connections won't work if the policies that are defined for IPsec and IKE are incompatible. The bottom half of this slide talks about diagnosing and resolving VPN gateway connectivity issues, doing some troubleshooting. So troubleshooting a VPN gateway might include doing things like validating network throughput from an on-premises resource to Azure. You could potentially also experience issues with configuration or functionality of third-party firewall or VPN devices. If you need to do troubleshooting in depth, make sure you know the logs that are available to you, such as your gateway, your tunnel, your route, IKE, and P2S or point-to-site diagnostic log. So it's important to know what information would be available to you in each log from an exam perspective. So make sure you know what content would be found in each of those logs and where it would help you with troubleshooting. Now we're switching over to a different type of VPN connection, and that is point-to-site. So we've been talking about site-to-site. Now we're talking about point-to-site. A point-to-site VPN gateway lets you create a secure connection to an Azure virtual network from an individual client computer. So the client computer is the point and the Azure virtual network is the site. So a point-to-site connection is initiated from the client computer. And so this solution or this model of VPN connections is useful for telecommuters who may need to have access to different Azure virtual networks from a remote location, from home, from a coffee shop, wherever they might be. Point-to-site VPNs can use one of the following types of protocols. The first one is OpenVPN protocol. And OpenVPN protocol supports connections from Android, iOS, Windows, Linux, Mac devices. This is probably the most flexible of the VPN protocols. You can also use Secure Socket Tunneling Protocol, SSTP. However, this can only be used with Windows devices. The third one is IKE version 2 VPN. This is a standards-based IPsec VPN solution, and this could be used as an example to connect from Mac devices, so it's not limited to Windows machines. Now, your point-to-site authentication methods. When you want to authenticate a user over a point-to-site VPN connection, there are two specific mechanisms that you can leverage, at least from the exam perspective. The first is authenticating using native Azure certificate authentication. So when you use the native Azure certificate authentication, there's a client certificate on the device that is used to authenticate the connecting user. The validation of that client certificate is performed by the VPN gateway, and it happens during the establishment of that point-to-site VPN connection. The second method of authenticating the connection or authenticating a user is using native Azure Active Directory authentication. So Azure AD authentication allows users to connect to Azure using their Azure Active Directory credentials. It's very important to remember that native Azure AD authentication is only supported for OpenVPN protocol and Windows 10, and it requires the use of the Azure VPN client. So you see a diagram down in the lower right corner of the tunnel type OpenVPN SSL. This is used with Azure Active Directory. Now, it's a good thing to know the steps involved in setting up that OpenVPN connection. So in the section there, plan of configure OpenVPN authentication, it would be a good idea to research or at least understand the steps that are required for configuring OpenVPN and integrating it with Azure Active Directory. On-premises AD domain authentication is also a popular option for authentication because it allows users to connect to Azure using their organization's domain credentials. So when you set this up, it requires a Radius server that integrates with your on-premises Active Directory. So the Radius server is deployed either on-premises or into your Azure virtual network. During the user's authentication process, the Azure VPN gateway is going to pass authentication messages back and forth between the Radius server and the connecting user device. Obviously, that means that the gateway itself has to be able to communicate with the Radius server. If the Radius server is present on premises, then there needs to be a VPN site-to-site connection from Azure to that on-premises location in order to attain that reachability for the Radius server. Continuing on with the point-to-site VPN connection discussion. If you want to connect to a virtual network over point-to-site VPN connections, you need to configure the client device that you'll be connecting from. So you can create point-to-site VPN connections from Windows machines, from Mac OS machines, and Linux client devices. When you're using Radius authentication, there are likewise multiple authentication options. So you can use username, password, you can use certificate authentication, and some other authentication types as well. The VPN client configuration in that case is going to be different for each type of authentication. You can create VPN client configuration files for Radius certificate authentication that use the EAP TLS protocol. And typically, an enterprise issued certificate is used to authenticate the user for VPN. So what you've got in the PowerShell boxes on the right-hand side are the different PowerShell commands that you would use to configure the different authentication methods for a user that might be using username password authentication or Radius certificate authentication. For the exam, you'll need to be familiar with ways you can troubleshoot VPN connections that aren't working as expected. So as the box points out, your VPN connection might be failing because you've incorrectly defined the gateway type. Maybe the formatting of the certificate or where you've placed the certificate, it can't find the certificate to establish the VPN connection. Or if there have been configuration changes to the network topology, it may require that you download a fresh copy of the VPN client in order to establish that VPN connection. Okay, moving on to ExpressRoute, Azure ExpressRoute. ExpressRoute Direct is one of the flavors of ExpressRoute. It gives you the ability to connect directly into Microsoft's global network at various peering locations that are strategically distributed around the world. ExpressRoute Direct gives you active connectivity at scale, and just about any service provider can help you get set up with ExpressRoute Direct. Now, just like with many of the services in Azure that we've talked about so far, when you create a virtual network gateway, you need to specify the gateway SKU and the tier of service that you want to use. When you select one of the higher end gateway SKUs, those machines that are running as a gateway may have more CPUs, they have a higher bandwidth capacity, more bandwidth is allocated to that gateway, and as a result, the gateway can support higher network throughput to the virtual network. So ExpressRoute virtual network gateways come in 3 different SKUs. There's standard, there's high performance, and then there's ultra performance. So make sure you know what the characteristics are of each of those SKUs for ExpressRoute so that you know what each of them can do and what each of them can't do. So a link to the gateway SKUs is in about the middle of the slide there. The last topic on the slide here is ExpressRoute Global Reach. And so with ExpressRoute Global Reach, you can link ExpressRoute circuits together to effectively create a private network between your on-premises networks in different parts of the world. So what you could do is connect your on-premises data centers using Microsoft's private backbone network. So you would establish a connection with ExpressRoute into Microsoft's network and then use Microsoft's worldwide network as a way of connecting your data centers. Global Reach does require an ExpressRoute premium SKU to enable that connectivity between the different geopolitical regions. So it's a good idea to understand the use cases for each type of ExpressRoute configuration, whether you're talking about local, FastPath, direct, or global reach. So continuing on the discussion of Azure ExpressRoute, let's talk about FastPath. So ExpressRoute FastPath is designed to improve the data path performance between your on-premises network and your Azure virtual network. So when you enable FastPath, it sends network traffic directly to virtual machines in the virtual network. So in effect, or in reality, you are bypassing the network gateway. The traffic goes directly to virtual machines in your virtual network. However, even though it isn't going across the gateway, FastPath still requires a virtual network gateway to be present so that it has the ability to exchange route information between the virtual network and the on-premises network. And again, that gateway needs to have a very specific type of SKU. There are 2 types of SKUs that support that configuration. Azure VMs and PaaS services that are deployed within a virtual network can be connected through private peering. And that's what we see up in the top diagram. So private peering is considered to be a trusted extension of your core network into Microsoft Azure. So you can set up bidirectional connectivity between your own core network on premises and Azure virtual networks. This peering lets you connect to virtual machines and cloud services directly on their private IP addresses. You can also use ExpressRoute to establish connectivity to Microsoft Online services, things like Microsoft 365 or Azure, using what we call Microsoft peering. So with Microsoft peering, Microsoft enables bidirectional connectivity between your WAN, your on-premises network, and Microsoft Cloud Services through the Microsoft peering routing domain. So you have direct connection to the Microsoft services over that dedicated connection. So it is important to know when you might use private peering and when you might use Microsoft peering. The last topics or set of topics that we're going to configure or discuss here under ExpressRoute are virtual network gateways and gateway types. So to connect your Azure virtual network and your on-premises network using ExpressRoute, you have to create a virtual network gateway first. Now, we mentioned this before. A virtual network gateway serves two purposes. First of all, it allows you to exchange IP routes between those two networks, and it also serves the purpose of being able to route that network traffic. When you create a virtual network gateway, again, you need to specify the gateway type, and that's either going to be an ExpressRoute gateway or a VPN gateway. And we already talked about the VPN gateway early on in this section. So if you're using the VPN gateway type, this means that you're okay sending encrypted traffic across the public internet. So you use the VPN gateway type. So your site-to-site, your point-to-site, and VNet to VNet connections all use a VPN gateway. If you use an ExpressRoute gateway, this means that you would rather send network traffic on a private connection, right? You're not sending this across the public internet. So you use the ExpressRoute gateway type when you set up your gateway. If you define defining default routes is permitted only on Azure private peering. So in that scenario, Microsoft is going to route all the traffic from any associated virtual networks to your on-premises network. If, however, you decide to advertise default routes into private peering, it can result in the internet path from Azure being blocked. You'll then have to rely on the corporate edge to route traffic to and from the internet for the services that you have located in Azure. You can use an Azure Virtual WAN to establish a VPN connection from your on-premises network to Azure over the private peering of an Azure ExpressRoute circuit. What this technique will do is provide you with an encrypted transit between the on-premises network and Azure virtual networks over ExpressRoute without going over the public internet or using any public IP addresses. So we saw this depicted, if you go back a slide, in the diagram of private peering site-to-site connection. The link on this slide is really just emphasizing the encryption configuration for that type of connection versus just describing the use case for that type of connection. ExpressRoute also supports what we call bidirectional forwarding detection, or BFD. That is supported on both private and Microsoft peering. So when you enable bidirectional forwarding detection on ExpressRoute, you can actually speed up the failure or the link failure detection between Microsoft Enterprise Edge devices and the routers that your ExpressRoute circuit gets configured with. In most cases, considering the last bullet point on this slide, you can troubleshoot most network issues using pretty basic tools, things like ping or traceroute. However, the Azure team has developed a toolkit that can help you with troubleshooting. It's called the Azure Connectivity Toolkit, or Azure CT. It was developed to put some of these tools into an easy package to use. So as an example, it contains performance testing tools like iPerf and PSPing, which can provide you with information about things like your network latency and performance. So make sure you know where tools like iPerf, PSPing, and the get link performance commandlet would be useful in your troubleshooting process.